Hey everybody, this is Mr. Conklin from my quote-unquote home studio down in my basement. Hi, this is my hand waving hello. I wanted to give a review video mainly of what we've been doing in this entire chapter, chapter 3. The main thing we've been doing is basically solving very large polynomials and all the various tricks we have for doing that. And eventually we also did some solving inequalities too, like blah, 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 blah is less than 0 and how to do that. We'll get into that in a little bit, but I just want to give you a quick example of what we've been doing. So for example, if I were to ask you to solve the following polynomial, and I'll get my hand out of the way in just a second. X to the fifth plus 3x to the fourth minus 3x cubed minus 9x squared plus 2x plus 6 equals 0. And if you remember, equals 0 is the sort of code for solve things. Anything equal to 0 is sort of math code for I want to solve this. I want to see what x equals. So let's see if we can do this. Now, at the beginning of the chapter, the only way we knew how to solve something this big was if we were lucky enough to have it factor. This thing is enormous. It's got a degree of 5. The degree is the highest power. So we, unfoil only works on degree 2. Magic pair only works on degree 2. Binomial squared works only on degree 2. Difference of two squares. It can work on bigger things, but only with 2 terms. Nothing seems to work. There's no GCF. It looks like we're dead in the water. Well, there is one method that does, and if you'll forgive me for adding the opposite, watch this. This is a little bit of a beefier version of factor by grouping than we've seen before, but it does work. Factor by grouping is normally 4 terms, and then you pull out the little mini GCF from each pair. You can also have more than 2 pairs. The only catch is they have to be what we call proportional. Like there's a 1 in front here. 1 goes to 3 as -3 goes to -9. That's proportional. That means you multiply by 3 to get the second term, multiply by 3 to get the second term, and this, multiply by 3 to get the second term. These are called proportional, which means that factor by grouping should work. Just for giggles, let's try it. This has a little mini GCF of x to the 4th, and left behind would be x plus 3. Now, the GCF of this one, remember, if it starts negative, pull out a negative. The mini GCF is -3x squared. And if you pull out the negative, the x will be positive plus 3, which is good. We want them to match. And then this will be plus 2 with an x plus 3 left behind equals 0. So it does seem to work. Factor by grouping only works if the parentheses are equal. And in this case, they are, which is good. There's a kitty hair on my paper here. It's an occupational hazard of living in this house. But I'm going to pull there's a GCF of x plus 3. I'm just going to pull that out in front. And left behind is x to the 4th plus -3x squared plus 2 equals 0. Now, a curious thing is we could do zero product property on this. Set this equal to 0, set this equal to 0. But this is awfully big still. I'm wondering if it factors again. The short answer is yes, it does. In second-year algebra and first-year algebra, we use something called substitution, where we did u equals x squared. This would transform into u squared plus -3u plus 2. You'd factor by unfoil, and then you put the u back where you found it. I'm going to just go a little bit faster there. And if you have any questions on this, just see me. Unfoil can work with bigger powers as long as it splits evenly. So no matter x to the 4th is x squared. Can you find two numbers that add up to -3 and multiply to be 2? Yeah, -2, -1. They multiply to be +2, and they add up to be -3. Now, do these factor? This one definitely does not. This is x plus 3. This thing doesn't seem to factor. We'll skip that for a second. This one does. This is difference of two squares. It's x plus 1, x minus 1. And I'm just going to keep this one as is, x squared minus 2. Technically, that does factor in pre-calc. Second-year algebra, we might have touched on it. First-year algebra, no way. This would have been prime. But you remember, difference of two squares is the first thing he square rooted and the second thing he square rooted. Like x squared minus 9 would have gone to x plus 3, x minus 3. X squared minus 25 would be x plus 5, x minus 5. In the same sort of way, if you wanted, you could split this. I can't talk. You could split this into x plus radical 2, x minus radical 2. I'm not going to do that because it's just as easy to set them all equal to 0. But just so you know, it does technically factor. So zero product property says set all these equal to 0. And let's see what we get. So x plus 3 equals 0. X squared minus 2 equals 0. X plus 1 equals 0. And x minus 1 equals 0. A lot of these you can just do in your head. This is x equals negative 3. There's one solution. I'm going to add 2 to both sides here. This is a two-step problem. So x squared equals 2. Now I need to square root, which, by the way, has two answers, positive and negative. So x equals radical 2. X equals negative radical 2. So there are two separate roots there. This, you just subtract 1, you'll get x equals negative 1. And here you add 1, so you get x equals positive 1. Now up here, you may notice I got 1, 2, 3, 4, 5 different roots. And that's all the solutions we're going to get. Because at the very beginning of the chapter, we found out that the highest power, which we call the degree of any polynomial is the highest power. And there's something interesting about that. Highest power, highest exponent, whatever you want to call it. In a polynomial like this, the degree will always tell you the number of roots. And remember, root is just another name for solution. We got 5 solutions. We call it 5 roots. But this is a mess. Sorry, this is supposed to be negative 1, and I circled right over it. So 1, 2, 3, 4, 5, and sure enough, the degree was 5. That will always be true. That's something called the fundamental theorem of algebra. The fundamental theorem of algebra, we do FTA for short. Fundamental theorem of algebra says in any polynomial, the degree is equal to the number of roots. And ta-da, there you go. Now again, this is kind of lucky. We had gotten a thing that actually factored by grouping. What happens if you have a polynomial that does not factor by grouping? Well, I'm going to put that in the next video. I just wanted you to, quote unquote, enjoy this for now. So I will take a break here for a second, grab a drink of water, and set up a new problem for you. So see you in a moment.